So in this video here, we're going to talk about if we have a room that's enough for itself. So it's the simplest case where you don't have an external geometric dependence. So it gives us the simplest building tree with the file, a body without a marker of origin, sketches that are actually supported on this marker, and a fairly basic construction. So this is the most classic case, so the simplest case of workflow. The simplest part is the unique part without any other constraints. So in this case, how's it going? Already you're creating a new file for your room. There it appears. We're going to give him a little name, so we're going to put this in my papers. Missing a piece. Here, you see that the file name appears here in the building tree. In most cases, I swear, you're going to use it mostly. If you do 3D printing, mechanics, wooden parts, I think that in 85% of cases, you will use the workbench, the workshop by design. So we take the workshop by design. We'll start by creating a body, so it creates, you see it appears there, body. I advise you to give it a name. I'm going to draw a hook for the clothes, so we're going to call it hook crochet, so it's bilingual, like a video. That's it, so it's all empty, so we see it actually contains only one mark. So a mark that's in the same place as the absolute reference to FreeCAD. So it's made up of 3 planes, X, Y, X, Z, Y, Z, and the 3 axes, X, Y, and Z. So you can press your first constructions, in fact, on these basic elements. So that's why we start by creating a body. So here I decide that I will draw my crochet on the X, Y plan. I select the plan, and then you go there on the Create Sketch icon. Create a sketch. And here, hop, it opens the Sketcher workshop, so to do sketches. So on this workshop you'll use it very often. It's one of the most important workshops. There are plenty of tools, lots of things to learn about this workshop. We're not going to get lost directly in the details. The only thing I'm going to tell you is that here you have building elements, and then the constraints. After that, there are a few other specific things we'll see later. So here, to draw this little ball hook that we're going to potentially do in 3D printing, I'm going to use almost one tool. It's polyline, so we just click on it. And then we'll draw on the fly. A little bit in proportion like that, as we think this crochet.y. So I start there, and then I want it to be pressed on the x-axis. I'm going to the beginning, we're doing it pretty much like that. Then we'll give him an angle. There'll be a certain thickness, about an equivalent segment. Now we're going down there. We've got the eye, we're keeping the thickness pretty much like that. And then we connect. We close the polyline like that. So right now, you see, I really drew my hook up like that. Quickly done, well done. Now, we're going to apply a few constraints on that to a little bit define all this more precisely. So we also start there always by applying non-dimensional constraints. That's what we're gonna say. So dimensional equalities, symmetries, segments that are parallel. So I want these 2 segments to be parallel. To select them, press Shift and then click on each other. And then you go to Constraint Parallels. Parallel constraints, here we go. You put them in parallels. This one here, I'd like it to be horizontal. So I force him horizontally. I'd like to have a constant thickness of my hook. So he and he are going to be equal. There you go. I'd like him to be perpendicular to that direction. I'd like him to be vertical. There you go. And now we're going to give 3 dimensions. So select this segment. After that, you just go here now in FreeCAD. That's great. There's everything that's been put together in one tool, actually. The tool dimensions. It allows you to intelligently select the constraint you need, don't you? So here in this case, we're going to choose the height of this segment. I'd like it to be about 55 mm long. After that, I'll set the total height of my hook. I'd like it to be about 120 mm between the base and the top. So I select the axis of reference on which I have based myself. Then I press Shift and click on the top of the hook. There you go. And we're taking that tool back. And then it offers me directly the height constraint. So now we're 76 mm away. We'll put 120 on it. There you go. The angle of my hook. Same thing. I select the axis. Shift. My segment. Automatic constraint. It allows me directly to have an angle constraint. I'll put 35 degrees. There you go. Here, the thickness of my hook. I want it to be 6 mm. So, automatic stress. It's magic. It's much easier now, this new version. So we're going to put 6 mm in there. Oh my god. There you go. Then here you can see that it's weird little things. We'll take it back manually. Anything that isn't forced is left blank. It can be manipulated freely. So here, the same thing. We're going to impose the thickness of 6 mm. There you go. Always the same process. In the Sketcher workshop, it's always the same if you make a multiple selection. You're pressing the capital key, Shift, and then you select the different items you want to select. So now we're doing this again. We're taking the x-axis auto. Shift, that top. Now we've got 7 mm. I want 6. There you go. So this is good. We're done with this. What's left of us here? We can see that we still have 2 dimensions that are not constrained. So it's that height and that dimension. So, my crochet in design. I like that part. So here, I'm going to define that little height. Ah, an effect. So there's a redundant constraint. That sounds orange. That's not what I wanted to do. So we either cancel or click on it. And then we delete it. So we select this segment. And we want to give it its dimension. So 12 mm. There you go. That's what I wanted to do. And the total length here, we select this segment. And I want him to be 50 mm tall. There you go. So right now you see my sketch, it's in green. It's all green. It means everything is forced, fully forced. It appears here. Fully constrained. So that means everything is well defined. There is no longer any degree of freedom. We are not always obliged, in fact, to fully compel our sketch. As we saw briefly before, I made a selection error. There was a conflict of constraints. In this case, the sketch becomes orange, and it warns you that there is a conflict. So you have to choose, in fact, what constraint takes precedence over the other. But we're not going to go into those details. Just keep in mind that once everything is okay, it appears in green, or it stays white. If it stays white, you've left some more degrees of freedom, which can be quite okay in many cases. Here, we're in orange. It's because there's a conflict of constraints. So now we have to go look. You have to remove the last constraint you put. We need to think a little bit, but that's not the theme of this video. So now we've created our sketch. We're closing the workshop. We can see he's here. We can hide the marker. The sketch is here. So we're back on our workflow. We created the file, a body in the file. We've created a sketch based on the marker. And then this sketch, now to create volume of materials, to create thread, we'll just extrude it with the extrusion pad tool. I want it to be 15 mm long. There you go. So it's the base of my crochet that's already done. Now more than just doing the additional operations, I want to add a drill to come and put on a screw. We're going to put this right in the middle. Then we can add some rays, some chamfers. And we did the workflow for the single piece. So here, to add a drill, you can simply click on the face on which you want to add that drill. Again, you come to create a sketch. There you go. To make it more convenient, I switch to wired mode. And then here, I just want to make a hole in the middle of the face. So the simplest way to do this without calculating anything is to use a symmetry constraint. So we're going to take as an external geometry with this tool here. External geometry, that ridge there and that ridge there reach. It makes the stop and the peaks appear. That way you can just put a circle in the middle. And then tell him, I want you to be in the middle of the face. So to do that, you select that top there. You press Shift, you select this top here. And you select the point that is at the center of the circle. And you come to choose the symmetry constraint. There's something wrong with that. We're gonna do KRLZ. So I'm going back. I select this summit, that top there, and the central summit. Symmetry. There you go. That's what I wanted to do. I think I made a mistake. When you're talking, it's always complicated. I interrupted. Come on, let's go back. So then, we put our circle in the middle of the face. You could set the diameter of the circle. But there is a tool that is more practical, because it's tiring to know the diameters of screws, etc. There's the drilling tool. Who's going to create a screw passage, actually, where there's a circle in your sketch? So, the principle is simply to position your circle. And wherever the circles are, it doesn't matter how big they are, actually. It's just the position of the circle that creates the screw passage. So you select your sketch. And then you click on the drill tool. And then you have direct access to the different standards. So I still work with ESO screws. And now I'm going to make a pass for an M3.5 or M3 screw dot. So you see it creates my piercing directly through my hook. Another really cool thing in this function is that it's okay. You can also directly. So now if you screw, in fact, there will be the screw head that's going to exceed. So you can, if you have screws in cheese head, you can directly open, have space for screw cutting. Or if it's screws in conical head, you choose here, conical head characteristics. And then it makes you directly the chamfer actually for your screw, that conical head. So that's what we're going to keep. Then there are the other standards. We're not going to go into that detail. So here we are, we've got our screws. So here, we just completed our room in terms of its functionality. That way we can fix it against the wall to make her a little bit prettier. So the last few operations, every time you do a room, you come to put on little rays. So, how's it going? You select the edges you want to radiate. After that, it's Ctrl to select several at a time. So here, then there. And you go on the Net tool. And Ottoman, it appears a ray on the edges you selected. So standard, it's a millimeter. You're increasing the size of the beam. We're going to put 5 mm, so it's well rounded. There you go. That way, it's a little more design. That's what we're gonna say. And we're gonna do the same thing. We'll add a little chamfer. So here you can either select the edges, either directly the faces actually. So right now we can look at these tools. Because sometimes it's a joke. So this is bullshit. So we would have been doing this like that. We're going to select this one instead. And in fact, the function, it spreads as far as it can. So now it's spread so far. That's very good. It ends there. That's the way we go. We can try to add, in fact, that stop. That's the end of it. 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 This one. This one. There you go. And this one again. Let's see if it's over. It's gone. So that's functions actually, for a little bit of groping. Because the result is not always guaranteed for all kinds of reasons. Good reasons. Things you haven't thought about. Or simply also small bugs in. Not necessarily actually in FreeCAD, but directly in fact in OpenCascade, the 3D computing and rendering engine that is at the heart of FreeCAD. So after that, it's the same thing in all CAD software. The commercial software I used before had the same kind of problem. To manage the creation of rays and then chamfers a little manually, and check that everything goes well when you add them at the end of the creation. So now we're good. I'm going to add some more chamfer here again. It'll make the room a little softer. And again in front twop. There you go. That way, it's not bad. Here, I have a lot of chamfers. That way, since it's going to be screwed against the wooden board. And under there, it's not necessary either. That way, when I print it in 3D, I'll get a better membership. Because we won't have chamfers on all sides. So here's my hook, so unique piece is finished. So that was the classic workflow for a single piece. So we sum up, we create the file. We create a body that contains a marker. On this marker, we're going to create a first sketch that will generate the original volume. Often, it will be with extrusion function or with revolution function. And then we have secondary operations like piercings, adding rays and chamfers. And then, here's your play, it's over. So that's really the typical workflow of the single piece that is actually enough for itself. So here he is. He's in the spot. So this is a simple case that happens very often, in fact. So if you want to learn how to master the software, I advise you to start by drawing this kind of pieces that depend on themselves. It actually limits the number of things to think about. Because you'll see in the other two examples that after, it makes things a little more complicated. So here's the thing, I hope it's taught you something. If you're interested, put a little emoji Grinch in the comments. I like this character. And don't forget to subscribe to the channel, to like, to share, to comment. Tell me about your feedback. I'm always curious to see how you perceive my content, and also make suggestions for content that may interest you. It can give me ideas. Thank you in advance. Thank you for looking.